lots of reactions are not just gases, right? There's solids, could be pure liquids, right? Kc is great for like aqueous solutions, the concentrations, but what if you have a solid involved or a pure liquid involved? Concentrations of solids and liquids don't change. And so you're like, well, wait a minute. Let's think about water. Right? Water is a pure liquid. What's the concentration of water? You can calculate the molarity of pure water. It really comes from its density. Because, let's say approximately 1 gram per milliliter, well, how many moles of water are in a gram? Divide that by 1 milliliter and then change it to liters. 55. Water is 55 molar. If you have a little tiny cup of water, it's 55 molar. If you fill the classroom with water, it's 55 molar. It doesn't matter how much you have, right? It just is what it is. It's the pure liquid. Okay? Solids. You could calculate a molarity for, say, a chunk of carbon. Does it matter how big or how small? No, it's the same molarity, right? So when some of this reacts, does that change its concentration? No, it doesn't. Since the concentration doesn't change, we leave it out of the equation. It doesn't have an effect on the equilibrium. So here, looking at 2CO in equilibrium with CO2, and C, where C is carbon, it's a solid. When we write the equilibrium expression, we don't include the C. It's not going to change, so we leave it out. Any questions? Let's practice one. Yes.
I'm supposed to remind you about ratios on that slide?
Yes, we're getting to that. Thank you. So here we're asked to write the equilibrium expression for this chemical reaction. So would this be Kc or Kp? Is it all gases? No, it's not all gases. There's aqueous things in there, and we can't really do a partial pressure for that. So this is going to be Kc. We're dealing with concentrations. So products over reactants, concentration of H plus to the 1 power, concentration of HCO3 minus to the 1 power, divided by concentration of CO2 to the 1 power. Do we divide by the concentration of pure liquid water? No, we leave it out. This also just saves a lot of work because it's like, if we included all of those, then it's like, okay, then, we need to know what the molarity of all these different things is, and that's tedious and unhelpful. Any questions? So you see liquid or solid as the physical state. See, this one's liquid. It doesn't show up. Gases, aqueous things, they can have concentrations. Let's do this one. It's asking for Kc. Products over reactants. Do we put CaO in there? No, it's a solid. So we've got the concentration of CO2 gas divided by the only reactant is also a solid. So this equilibrium constant is the same as the concentration of CO2. Doesn't depend on how much of those solids you have. It would be related to the concentration. The concentration isn't changing.
And here the units go away.
haven't gotten to anything with numbers for concentrations. That's what I'm looking for. We don't have numbers yet. They're coming. They're coming. Any other questions? Here's another example. Really don't think we need this many examples, but we've got lots of time, so whatever. So what would the numerator be? Cl2 squared, right, divided by HCl to the fourth power and O2 to the first power.
Since it's three gases, do we choose KP?
You could use Kp, but they said do Kc. Yeah. Yes?
Why is the water not as well?
Because it's a pure liquid and its concentration doesn't change. Any other questions? Yeah.
I had a question. So you said it's because it's a pure liquid, it doesn't have a change in concentration.
Mm-hmm.
Okay.
Yeah. Most of the time, like if we have aqueous solutions, water is not actually one of the reactants or products. It's just what everything is swimming around in, so it doesn't even show up. Here, water is an actual product of this. But its concentration doesn't change if you have a drop or a tablespoon. It's the same concentration. So they're just left out. Okay? For which of these reactions does Kp equal Kc? This looks like a good exam question. What are we looking for? Equal moles of gases, right? How many moles of gases over here? 2. And how many over there? Only 1. Okay, that's not the answer. How about this one? 3 and 3. That looks like a winner. Let's check the last one. No moles of gas and 3 moles of gas. Okay?